warahmatullahi wabarakatuh, and hi everyone. So in this video we are going to look at the solution for program DM025 for set 5. So let's take a look at section E, question 1. Okay, question 1a, by using the first principle, find the derivative of fx equals to 1 over 1 minus x squared. So let's take a look at the first question, question 1a. Okay, to solve question 1a, first we need to know the formula for first principle. Okay, so the formula for first principle is f prime x equals to limit h approaches 0 fx plus h minus fx over h. So first thing you need to find your fx. Okay, they're already given you in the question, and then we find the function f x plus h. Okay, so fx plus h equals to 1 over 1 minus bracket x plus h squared. Okay, after that we just substitute these two functions into this formula, and if you notice here we factor out 1 over h, okay, and then substitute fx plus h minus fx. So this is your first mark, K1, and then next step you need to cross multiply this fraction. So 1 minus x squared, cross multiply, you will get 1 minus x squared minus 1 plus x plus h squared, because you have negative sign here. So negative 1 times 1, negative 1. Negative 1 times negative x plus h squared is positive x plus h squared. And your denominator, just multiply these two terms. Okay, so that is K1, and then you simplify the numerator. Okay, to simplify this numerator, first you need to expand this quadratic. Okay, so you expand this quadratic, you will get x squared plus 2xh plus h squared. Okay, so from here you can see that 1 minus 1, you will simplify, you cancel out 1, negative x squared plus x squared, so this also cancel out, so you are left with term 2x h plus h squared on the numerator. Denominator just left as it is. Okay, so numerator you will get 2xh plus h squared. Then you evaluate limit h approaches 0. Okay, before you evaluate, you can see here we have 2xh plus h squared on the numerator. So if you factor out h, okay, this is K1, you simplify. Okay, if you factor out h, you can simplify h here with h on 1 over h on the outside of the bracket here. Okay, then you evaluate. We can simplify this one. Then you evaluate h approaches 0. So this one approaches 0, numerator you will get 2x. Denominator, okay, h approaches 0, you will get 1 minus x squared times 1 minus x squared. Okay, so you will get your answer 2x over 1 minus x squared square. Okay, so that is answer for question 1e. Okay, so next, so that is your final marks, G1. So K1, 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 G1, 4 marks. Next, question 1b, they want you to find the derivative, the first derivative, dy dx when x equals to 1. Okay, when you look at this question, okay, it is actually, okay, two functions that are multiplied together. So this is your fx multiplied with gx. Okay, so to differentiate two functions that are multiplied together, we can use technique of integration, which is product rule. Okay, you can use formula. You can use product rule. Okay, so product rule, the formula is u v prime plus vu prime. Okay, product rule. So usually u is the front function and v at the back function at the back. So find your u and your u prime, v and your v prime. Okay, so here you will get your u is 3x, so u multiply with all of this is v prime. Okay, plus this one is v, this is u prime. Okay, so u 3x multiplied with, you need to differentiate v. This is our v, gx. Okay, gx is our v. So v prime is a function with power here. Okay, you have function and then you have power on the outside. So how to differentiate function that have power? So first you bring power to the front. Okay, so that's why you have 2 here, and then you copy back the function inside the bracket, which is 2x minus 1 over x squared, and then you subtract 1 from the power. So power is 2 minus 1, okay, is 1, and then multiply with differentiate inside bracket. So differentiate inside bracket, differentiate 2, okay, differentiate 2, differentiate 2x, you will get 2. Differentiate negative 1 over x squared, you will get 2, positive 2 over x, right? And then plus with v, copy back your function, gx, this is u dot v. Okay, so v, copy back the function v, and then multiply with u prime. You differentiate 3x, you get 3. Okay, so this, we have 2 marks here. Okay, k1, k1. And then when x equals to 1, substitute 1, replace x with 1, so you get 3 times, okay, this one 1, 1, so 1 times 1, 1, 1 minus 1. So 2 times 2 minus 1, this one 2, copy back, okay, plus 2 over 1, so 2 plus 2. Plus, okay, 2 minus 1 square times 3. Okay, so this is another k1, 1 marks, and your j1 is your final answer, 27. Okay, so that is the solution for question 1b, section A. Okay, so next we look at question 2 for section A. Okay, 2a, by using substitution u square equals to 3 plus 4x, find the exact value of your integration from 0 to 1, 8 over square root 3 plus 4x dx. And then b, they want you to evaluate this integral. Okay, so let's take a look at question 2a first. So for question 2a, they gave you this integral, and they also give you the substitution that you need to use. So they give you the question u square equals to 3 plus 4x. Okay, so if we square root both sides, okay, we square root both sides, you will get u equals to square root 3 plus 4x. As you can see here, square root 3 plus 4x is our denominator. So you can just directly use this substitution. Okay, and then you differentiate your u with respect to x. So du dx, okay, this is a power rule, you can use power rule. So set is actually, this function is 3 plus 4x power of 1 over 2. Okay, set is, the power is 1 over 2. You can change into power from 1 over 2. Okay, so you differentiate this one, 1 over 2, bring to the front, copy back the function 3 plus 4x, and then power 1 over 2 minus 1, you get negative 1 over 2, times with multiply, differentiate inside the bracket. Differentiate inside bracket, this one you get 0, this one you get 4. So that's why you have 4 here. Okay, and then you simplify the function, this is 2, 4, simplify, you get 2, and here we have negative 1 over 2. Since it's negative, then your set will be on the denominator. Okay, so 2 over square root 3 plus 4x. So these two step contributes to 2 marks, K1, G1. And then since we need to use substitution, you need to change the limit of the integrals. So this is limit for x. Okay, so when x equals to 0, you need to find limit for u. So use this function here. Okay, so when x is 0, your u is set 3. Okay, 0, u is set 3. When x equals to 1, so 3 plus 4, you will get your u is set 7. Okay, so that is K1. And then rewrite this integral in terms of u. So limit 0 becomes set 3, 1 becomes set 7. Okay, 8 you copy back. Okay, square root 3 plus 4x, this one is our u. And then here actually you multiply with dx. All of these are dx. Where do I get this? From this one. Okay, so make dx as a subject. You will get square root 3 plus 4x over 2 du. Okay, so this is our dx. Okay, then as you can see here, we still have square root 3 plus 4x. So this is our u. So substitute u. Okay, we need to make sure everything is in terms of u if you use substitution. Okay, so you will get 8 over u times u over 2. So simplify all this, you will get, okay, this is K1. Simplify all this, you will get integration from set 3 to set 7 for du. Okay, so integrate 4, you will get 4u. Okay, don't forget the lower and upper limit. This is K1, and then final mark is for your answer. Substitute your upper and lower limit. So this is your G1. Okay, so that is question 2A. Okay, next for question 2B. Okay, so for question 2B, they give you the integral from negative 2 to 2. Okay, 2x plus modulus x minus 1 dx. Okay, so for this question, if you see modulus sign, then we need to define the function first. Okay, as we know, as we have learned, okay, the basic definition, okay, you have a modulus x, so you can define it into two functions. First, positive x for x greater than equal 0, and then negative x for x less than 0. Okay, since we have modulus x minus 1, so modulus x minus 1 equals to, copy back the function, so x minus 1 for x minus 1 greater than equal 0, and then this one negative x minus 1 for x minus 1 less than 0. So here you will get your function x minus 1 for x. Bring negative 1 to the right hand side, x greater than equals to 1. This one is negative x plus 1, or rearrange 1 minus x. Okay, for x less than 1. Okay, is it clear? So define first. As you can see, okay, there is a different function. For x greater than 1, greater than equal 1, you will use function x minus 1. For x less than 1, you need to use function 1 minus x. So since the integral is from negative 2 to 2, so it's include value 1 here. So we need to split this function into two terms. Alright? Okay. So you will get your integral like this, integrate from -2 to 1. Okay, so this is value less than 1. So from -2 to 1, value less than 1, you will choose function 1 minus x over here. This one, 1 minus x for x less than 1. Okay, so that's why 2x, you need to plus with 1 minus x, and then plus, integrate from 1 to 2, 2x plus x minus 1. Okay, this one, x minus 1 for value x greater than equals to 1. Okay, so we are using two different functions here based on the interval given. Okay, so that is your k1. And then next, you integrate these two functions. So you can simplify first. 2x minus x is x. So x plus 1. This one, 2x plus x is 3x minus 1. So integrate x, you will get x squared over 2 plus x. Integrate 3x, you get 3x squared over 2 minus x. Evaluate from -2 to 1, 1 to 2. So another 2 marks here. J1, J1. And then you substitute your your upper limit and lower limit. And then this is K1. You solve, you get your final answer 5, which is your final marks J1. Okay, so we have total 5 marks here. So that is for question 2B. Okay, so next we look at the next question in section A, which is question 3. Okay, the last question in section A. So for question 3, the figure below shows the region bounded by the curve y equals to 4x minus x cubed. As you can see, we have a cubic function, so your cubic function shape is like this. Okay, and the region is bounded by the curve and the x-axis. So this is our shaded region here. Okay, find the area of shaded region. So we need to find this area. Okay, since we have two different areas, so I let this is region A and region B. Okay, so the area for the region bounded by the curve is A plus B. Okay, so let's recap the formula to find area. So you need to use form integration. Okay, so y top minus y bottom dx. Okay, so what is y top? The function on the top minus function on the bottom. So for example here, for area A, okay, your y top, you need to integrate from -2 to 0. This is 0. So you need to integrate from -2 to 0. Your y top is x-axis, means 0, minus your y bottom. This is y top, this is y bottom. So y bottom is your function for x minus x cubed dx, and then you plus with integrate from 0 to 2 y top for x minus x cubed. Okay, minus with your y bottom is x-axis, so minus 0. Okay, so this is the function that you need to solve, right, to find the area of the shaded region. Okay, so the solution area, okay, as I have mentioned just now, okay, you have negative sign here from -2 to 0 because of the formula y top minus y bottom. So this is actually 0 minus 4x minus x cubed. Okay, so this one is k1, 2 marks here, and then you integrate this function. First, multiply the sign inside the bracket, so you will get negative 4x plus x cubed. Okay, so you have integrate x cubed, you will have x power 4 over 4 minus x squared over 2, evaluate from -2 to 0, plus 4x squared over 2 minus x cubed, x power 4 over 4. Okay, from 0 to 2. So this is another 2 marks, J1, J1, and then you substitute upper limit minus lower limit, another K1, and then you solve, you get your final answer 8 unit square. So your area is 8 unit square. Okay, so that is the solution for question 3, section A. Okay, now let's take a look at section B. Okay, whereby we have total 7 question, question 1 until question 7 for section B. So let's take a look at the first question. Question 1. Okay, section B. So A, they want you to differentiate the following with respect to x. And then B, they give you a function. They want you to find the value of dy dx at x equals to 1 over 3 ln 2. Okay, and then C, they're giving you x equals to a function x in terms of y. And then they want you to show dy dx equals to y over 3 plus 3y. So we look at the first question, 1A first. 1A1 first, okay? So 1A1, they give you function y equals to cos cube x square, okay? Cos cube x square. So your derivative would be, okay, since you have power here, bring power to the front. So don't forget dy dx. dy dx equals to power bring to the front 3 times with, copy back your function, but subtract 1 from the power here. So 3 minus 1 is 2. Okay, and then this is the angle, just write down. And then you differentiate with the trigonometric function. So your trigo function here is cos. So differentiate cos x square. Okay, you doesn't need to include the power. Okay, just differentiate the trigo function and then multiply with, differentiate the inside the bracket here, x square. So that is the step, okay, to integrate a trigo function, to differentiate a trigo function. 3 bring to the front and then power subtract 1, differentiate trigo function, differentiate inside bracket. So your answer here, this is 3 cos square x square, differentiate cos, you get negative sign, and then differentiate x square here, you will get 2x. Okay, so this is your marks K1, another mark K1, and then final answer, simplify 3. So 3 times negative 1 times 2x, so you get negative 6x, cos square x square, sine x square. Okay, so that is J1. Alright, so next, question 1A2. So 1A2, they give you function y equals to e power of x minus 1 over e power of x plus 1. So this is actually u over v. You can use quotient rule. Okay, you can use quotient rule, which is vu prime minus uv prime over v square. So you need to find your value for u prime, v prime. So your u is e power of x minus 1. Differentiate u, you will get e power of x. V is ex, e power of x plus 1. Your v prime is ex. So that is K1G1. Okay, after you find u prime, v prime, you substitute into the quotient rule formula. Okay, so this is your v, this is your u prime minus u v prime over v square. So that is K1, and then you simplify by multiply ex, e power of x inside the bracket. Okay, so you will get ex times ex, you will get e power of 2x plus e power of x minus e power of 2x plus e power of x. Okay, and then here, okay, let me correct the answer. So e2x minus e2x you will cancel out, you will get 0. So e power of x plus e power of x, you will get 2 e power of x, 2 e power of x over e power of x plus 1 squared. So that is your G1. Okay, there is a correction in the answer scheme. Okay, so that is the answer. So next, okay, that is question 1A. Question 1A2. So now let's take a look at question 1B. Okay, question 1B, they give you function y equals to 2 plus e power of 3x power of 3 over 2. Okay, they want you to find the first derivative and then evaluate the value when x equals to 1 over 3 ln 2. So first find the first derivative, dy dx. Okay, so this one is a power rule, right? So bring power to the front, 3 over 2, copy back the function inside bracket, and then power, you subtract 1. So 3 over 2 minus 1, you will get 1 over 2, and then multiply with differentiate bracket. So differentiate 2, you get 0, differentiate e power of 3x. First, you copy back your exponential function, e power of 3x, and then multiply with differentiate power. So you differentiate 3x, here you get 3. So that's why you have 3 times e power of 3x. So that is K1. And then J1, you simplify this function. So this 3 times 3, you get 9. 9 over 2, e power of 3x times 2 plus e power of 3x, power of 1 over 2. So that is J1. Okay. So we substitute, okay, x equals to 1 over 3 ln 2 inside our first derivative here. Okay, so find the value. So substitute your x, you will get your third marks, okay, K1. And then as you can see here, we can simplify 3, 3, 3, 3. Okay, so you are left with 9 over 2 e ln 2 times 2 plus e ln 2 power of 1 over 2. So e ln 2, you will get 2. Okay, from the properties, e ln a equals to a. Okay, you will get the constant. So e ln 2 is 2. 2 plus 2 power of 1 over 2. Evaluate the value, you will get your answer 18. So that is your final marks, G1. Total here is 5 marks. Okay, so that is question 1B. And then question 1C. Okay, for question 1C, they give you function x in terms of y, and then they want you to show the function, okay, dy dx equals to 1 over 3 plus 3 over y. So first, you use the properties of log, or law of logarithm here. Okay, so law of log, if you have power, this power you can bring to the front. So that's why x is equal to 3 over 2 ln y squared plus 9. Only then you differentiate x with respect to y. So differentiate x with respect to y, you will write down as dx over dy. Okay, so dx over dy equals to 3 over 2. Just copy back, okay. You differentiate ln, you get 1 over y squared plus 9. Multiply with differentiate bracket, differentiate 2y squared, you will get 2y. Differentiate 9, you will get 0. So that's why here it is 2y. Okay, so that is your first mark, and then your second mark, you simplify. You have 2 here, so you can simplify 2, 2. So you are left with 3 times y over y squared plus 9. Okay, that is your second mark. And then the question wants you to show dy over dx. Right now, you have dx over dy. So what do we need to do to this derivative? We just switch. Okay, you switch the function. So dy over dx. So you will get y squared plus 9. Okay, switch the function. So y squared plus 9 over 3y. Okay, 3y will become the denominator, and then y squared plus 9 will become the numerator. And you can simplify this function because this is a basic fraction. So y squared over 3y plus 9 over 3y. Okay, so y squared over y, you will get y over 3 here. This is 9 over 3y, you will get 3 over y. Okay, just simplify this function. So that is your J1, you already shown. Okay, here you can simplify. This one you simplify, you get 3. Okay, alright, so question 1C, okay, done. Now let's look at question 2 for section B. Question 2, they gave you function y equals to x e power of x squared. Find your first derivative and then find your second derivative. For B, they want you to show this equation equals to 0. So, question 2A, to find the first derivative, as you can see here, this is two functions that are multiplied together, u dot v. So, you can use product rule. Okay, so formula for product rule is u v prime plus vu prime. Okay, so dy over dx equals to u v prime plus vu prime. Okay, your v prime here, as you can see, we need to differentiate e power of x squared. So first copy back your exponential function e power of x squared and then multiply with differentiate power. Differentiate x squared, you get 2x here. Okay, so 2x times e power of x squared plus v, copy back, you differentiate u, you differentiate x, you get 1. So that is k1, and then you simplify the function, x you multiply, you get 2x squared, e power of x squared plus e power of x squared, another marks J1. Okay, so that is first derivative. Second derivative, you take the first derivative, you differentiate again. Okay, so that is the meaning of second derivative. So this is your first derivative, differentiate again, but look at your first derivative, you have two functions here. So this is also your u dot v. Okay, you need to use product rule on the first term. Second term, just differentiate as usual. Okay, so your u is 2x squared. So u times v prime. Differentiate e power of x squared, you will get 2x e power of x squared plus, okay, u v prime plus v u prime. So v you copy back, e x power of x squared times u prime. Okay, you differentiate 2x squared, bring 2 to the front, you get 4. And then power minus 1, so x. Plus, okay, at the back here is this term. We just differentiate as usual. Okay, you get 2x times e power of x squared. So that is your k1. Okay, and then your final marks is for simplify. So you factor out the common term here. So factor out 2x times e power of x squared times 2x squared plus 1 plus 4x times e power of x squared. So that is your G1. Okay, so that is question 2A. We already find our first derivative and second derivative. For question 2B, they want you to show that this equation is equal to 0. Left hand side equals to right hand side. So your job is to substitute the function that you already find in 2A. Okay, the first derivative and second derivative, substitute on the left hand side, and you need to show that left hand side is equivalent to right hand side, equals to 0. Okay, so I just substitute dx square over d square y over dx square. Okay, this is a function that we already find in 2A. Okay, minus 2x times dy dx minus 4y. Okay, remember this is our y. Alright, and then that is your k1. Another k1 is you simplify. Okay, you simplify this function. you multiply inside bracket. So 2x times ex square times 2x square, you will get 4x cubed e power of x square plus, okay, 4x e power of x square minus 2x times 2x square, 4x cubed e power of x square, okay, minus 2x e power of x square minus 4x e power of x square. Okay, just multiply all term inside the bracket. You simplify everything. Okay, and then as you can see here, okay, this term and this term will cancel out. 4x cubed minus 4x cubed ex square, this thing also will cancel out. So you will get 0 shown. Okay, your last mark. Alright, so that is question 2b. You already shown that left hand side equals to right hand side. Okay, next we look at question 3 for section B. Question 3. Okay, we have two questions here, 3a and 3b. They give you function fx. Okay, a function f is defined as f theta equals to sine theta minus cos theta over sine theta plus cos theta. Okay, so A show that f prime theta equals to 2 over sine theta plus cos theta square. And then B, by substituting u equals to sine theta plus cos theta, they want you to integrate your f theta d theta. Okay, so A, first we show that our first derivative is equivalent to 2 over sine theta plus cos theta square. So write down your f theta first. To differentiate this function, you can see it is in terms of u over v. Okay, so we can use quotient rule. So formula for quotient rule is vu prime minus uv prime over v square. So find your u prime, v prime first. So u is your numerator, sine theta minus cos theta. Your u prime, you differentiate sine theta, you got cos theta. Differentiate negative cos, you get positive sine. Okay, and then v, your denominator, sine theta plus cos theta. So v prime is equals to cos theta minus sine theta. So K1G1 here. You substitute your u prime, v prime into this formula, quotient rule formula. You will get like this. Okay, so this is your v, this is your u prime here, minus u v prime, okay, over v square. This is v square. Alright, and then K1 for substitute into the formula, and then another K1, you expand the bracket here. So expand one by one. So multiply one by one, you will get this function below. So sine theta cos theta plus sine square plus cos square plus cos times sine. Okay, sine theta cos theta. And then same thing as the second term. The only difference is the sign here. So you have negative sign here. So negative sine square theta minus cos square theta. Okay, plus sine theta cos theta. And then, okay, this is another K1. And then you can see that from here we can simplify our function. So sine theta cos theta plus sine theta cos theta is actually 2 sine theta cos theta. Okay, so 2 sine theta cos theta, and then you have minus sign here. So sine theta cos theta, sine theta cos theta. So 2 sine theta cos theta minus 2 sine theta cos theta. So this term will cancel out each other. Okay, so you are left with sine square theta plus cos square theta minus sine square theta plus cos square theta. Here why plus? Because we have already factored out negative here. Okay, so please be careful. If you don't want to factor out, Okay, just write down negative here. But to make this simple, so we factor out negative. Okay, so by using the trigonometric identity, sine square theta plus cos square theta equals to 1. So here 1 minus, so plus 1 plus 1. Okay, so this is 1 mark. And then J1 when you simplify this function. So you already shown the function f prime theta equals to 2 over sine theta plus cos theta square. Right? So that is for question 3a. For question 3b, okay, they want you to use a substitution. They want you to integrate f theta d theta. So your f theta is sine theta minus cos theta over sine theta plus cos theta. So they said by substituting u equals to sine theta cos theta, okay, they want you to integrate. So we can use integration by substitution. So u is sine theta cos theta, du over d theta is cos theta minus sine theta. Okay, differentiate sine, you get cos, differentiate cos, you get negative sine. And then this is k1. Okay, we need to integrate this function by using substitution. So numerator you copy back sine theta minus cos theta. Denominator is your u. Okay, this is your u. So change into u. And then d theta here, you get from here. Okay, so du over cos theta minus sine theta equals to d theta. Okay, here. I substitute here. Right? So that is K1. And then you need to simplify this function. Okay, the only difference here is this is sine theta minus cos theta. This is cos theta minus sine theta. If I factor out negative, I will get negative sine theta minus cos theta. Okay, so after I factor out negative, I can simplify these two terms. Okay, so you will get integrate negative. So negative come from here. Negative 1 over u du. This is K1. And then integrate 1 over u, you will get ln u. So negative just carry forward. Negative ln u plus c. This is K1. And then substitute back your u. U is sine theta plus cos theta. You will get your answer. Negative ln sine theta plus cos theta plus c. J1. Don't forget c, your constant, because this is indefinite integral. So that is the answer for question 3b. Question 4, they want you to use integration by part. Okay, stated in the question, use integration by part. Okay, to show that left hand side equals to right hand side. Okay, so we take a look at the solution. So they want you to show that the integrals of 4 ln x over x cubed dx, okay, equals to 1 plus negative 1 plus 2 ln x over x squared plus c. Okay, so here they want you to show this. Okay, since they mentioned by using integration by parts, so you need to use law pad. Okay, to choose u, you need to use law pad. Okay, integration by part. So here we have log and polynomial. So your u should be log because of log pad here. So u will become ln x. Okay, and then you differentiate u, you will get 1 over x dx. And then your dv is everything other than ln x. So dv is 4 over x cubed dx. You integrate both sides. Okay, you will get v equals to integration of 4x power of negative 3 dx. We just bring x cubed to the numerator. So you will get negative sign here. Integrate, you will get 4x power of negative 2 over negative 2. Simplify, you have negative 2 over x squared. So this is J1. Remember, power you must, for integration, power you must add 1. So negative 3 plus 1, you will get negative 2, and then you divide by your power, then negative 2. Okay, integrate, power you must add 1. Okay, so after you find u, du, dv, and v, substitute into your integration by part formula. Integrate u dv equals to uv minus integration v du. Okay, you substitute, you get k1. So here you just simplify uv. At the back here, you still need to solve the integration. So here you get integration negative 2 over x cubed. Okay, so 2 over x cubed means that 2 times x power of negative 3. Bring x cubed to the numerator. So negative here and here becomes positive. So you will have negative 2 ln x over x squared plus 2x power negative 2 over negative 2 plus c. This is k1. Okay, you integrate this, you get 2x power negative 2 over negative 2. And then simplify, this will become 1. And then negative sign here. Okay. Here you will have negative 2 ln x minus 1. Okay. Over x squared. Okay. Plus c. So now factor out negative 1 to the front. You will have negative 2 ln x plus 1 over x squared. Actually, you have plus c here. Okay, don't forget plus c. So that is your final marks, J1. Okay, and then next question. So that is question 4. Question 5, you have A, B, C. Okay, let's take a look at 5a first. By using substitution, u equals to x squared, followed by the integration by part to find integration of x cubed e x squared. Okay, so they mention here, use substitution followed by integration by part. Okay, so if you look at the question, okay, so as mentioned in the question, okay, they give you function x cubed times e x squared dx. So they mentioned in the question, use substitution u equals to x squared. So first you need to factor out x squared here. Okay, so you need to let u, your u here is x squared. Okay, because the question already mentioned. Okay, u must be x squared. So your du is 2x dx. And then followed by integration by part, right? So if your u is x squared, so your dv is all this. This is dv. So dv is x times e power of x squared. So you integrate both sides. You integrate both sides. Okay, integrate both sides. You will get v equals to integration of x e power of x squared. Okay, now the answer is 1 over 2 e power of x squared. To get 1 over 2 e power of x squared, okay, this is 2 marks here, you need to use integration by part. Okay, this is also integration by part. So how? Show you. So integration of x times e power of x squared dx, you need to choose your u. So your u here would be x squared. Okay, so your du is 2x dx. Substitute into the, because this is by part, sorry, this is by substitution. Alright, so this one is by part. Okay, this one is by substitution. Okay, your u is x squared. Okay, so your du is 2x dx. So dx equals to du over 2x. So substitute your u into the function, integrate x e power of u, dx is du over 2x. So here you will get, simplify 1 over 2, integrate 1 over 2, eu du. Okay, this one is by substitution. Okay, sorry for the confusion of just now. Okay, so this is by substitution. This one is by part. Okay, so integrate 1 over 2 times eu du. So you will get 1 over 2 eu. U is x squared, so you get 1 over 2 e power of x squared. So this is our answer here. Okay, and then you substitute your u, your v, du, and dv into the by part formula. You get k1. Okay, so this is u, this is v over here, times integration v du. Next, you need to solve this integration. This one, you just simplify this function. So to solve this integral, as you can see, we get back the same function here. So integrate x e power of x squared. So I can just use the same method here. Okay, so this is k1. You use the same method, you will get your answer. X e power of x squared is 1 over 2 times e power of x squared plus c. Okay, so that is your final answer. Don't forget plus c here. Okay, so that is 5a. Now 5b, you need to solve the integral. Okay, for question 5b, but they already gave you the substitution. So your u, your substitution u is 3 plus 2 sine theta. Okay, so we find our du d theta. So differentiate u, you get 2 cos theta. Differentiate 3, you get 0. And then don't forget to change your limit, since this is in terms of theta. You need to change in terms of u. So this is d theta. So when theta 0, your u is 3 plus 2 sine 0 equals to 3. When your theta is pi over 6, your u is 3 plus 2 sine pi over 6 equivalent to 4. So this is 2 marks, k1, j1. And then you change the form from in terms of theta, you change it to in terms of u. Okay, so here 0 becomes 3, pi over 6 becomes 4. And then your cos theta here, okay, you simplify. So 3 plus 2 sine theta is u. So cos theta over u squared times with d theta. So to get d theta from here, so you get d theta equals to du over 2 cos theta. Okay, so I just substitute d theta into the function. So du over 2 cos theta. So simplify, you get 1 over 2 u squared du. Okay, so this is k1, and then you integrate 1 over 2 u squared. So you get negative 1 over 2u. Evaluate from 3 to 4. Okay, substitute upper minus lower. 4 minus 3. Another k1, and final answer 1 over 24 is your j1. So this is integration by substitution. Okay, so don't forget to change the limit from theta to u. So next, for question 5c. Okay, question 5c, they want you to integrate from 1 to e x power 5 ln x. So this one is by part, since you have two functions here. Okay, you can use Lopet method. So here we have log and exponential. So your u must be, to choose u, you must use Lopet order. So your u must be ln x. Okay, so du is 1 over x dx. So dv is the rest of it. This one is your dv. So integrate both sides. You get v is x power 6 over 6. That is k1, j1. Substitute into the by part formula. Okay, uv minus integration v du. Don't forget the upper and lower limit. You will get this function. Okay, this is K1. And then you need to simplify this. You need to solve this integration. So first, x power of 6 over 6 times 1 over x dx. So this one, you will get x power of 5. Okay, you integrate 1 over 6, I bring outside. X power of 5. Okay, you will get x power of 6 over 36. Because x power of 6 over 6, 6 times 6, you will get 36 here. Alright, so you combine these two functions, evaluate from 1 to e. Okay, upper limit minus lower limit, K1, and then final answer, J1. Okay, your answer must be in terms of E. Okay, the question already stated that your answer must be in terms of E. Okay, so that is for question 5. Next, question 6. So question 6, the figure below shows the curve y equals to x squared and line 3x plus y equals to 10. Find the coordinate of P and Q and also the area of shaded region. So this is the area of shaded region. Okay, so for question 6, okay, they want you to find the coordinate of P and Q. So to find the coordinate of P and Q, so first for point P, you need to equate these two functions. So y equals to x squared, you must equate with 3x plus y equals to 10. Okay, first change this question y in terms of x, so y equals to 10 minus 3x. You equate these two functions, so x squared equals to 10 minus 3x, okay. You have a quadratic function, you factor out, you get two value, okay, negative 5 or 2. But since, okay, your P must be in the first quadrant, okay, your x must be positive value, okay, your value cannot be negative, so negative 5 will be here. So we reject negative 5, we accept x equals to 2. So when x equals to 2, use this equation to find your value y, or you can also use y square. Y equals to 2 square, you will get 4. So your coordinate is 2, 4. So that is K1, this one is the first K, this is the second K1, and then for value Q, coordinate Q, since we know that the straight line y equals to 10 minus 3x intercept at x axis, so your y must be 0 at Q. Okay, so equate 10 minus 3x equals 0, you get x is 10 over 3, so this is your coordinate, so your J1. So this is 10 over 3. This is 4. Okay, this is 0. So 3 marks. And then next, they want you to find the area under the curve. So this is the area under the curve. This is 0.20. This is 0.4. This is 10 over 3. Okay, so formula area. You integrate from 0 to 2, and then your function here, the first part is x squared. Okay, plus with, this one is actually triangle. So you can use formula triangle. Formula area triangle is 1 over 2 times base times height. So 1 over 2 times base here 10 over 3 minus 2. Okay, so 10 over 3 minus 2, you will get 4 over 3. Okay, times with height, your height is 4. So you will get, so you integrate here, you get x cubed over 3, evaluate from 0 to 2, plus this one is 8 over 3. So evaluate upper minus lower limit, you will get 8 over 3 plus 8 over 3. So area is 16 over 3 unit square. Okay, so K1 for the first step, and then K1, G1. K1 and then G1, your answer 16 over 3. Okay, so the last question for section B. M is the region in the first quadrant enclosed by the curve y equals to 4 minus x plus 1 square with the x and y axis. Find the area. Okay, and then we look at question B later on. Okay, so 7A, find the region M. First, you need to know the area. Where is your area? M. Okay, so first thing first, look at the function here. This is a quadratic function in terms of completing the square form. Okay, so to sketch this function, actually for, okay, by using y dot sim, y dot sim. Okay, so you look at this function here. This is quadratic with negative sign, so you have an upside down smile there, and then your point of symmetry, you take the value inside the bracket, x plus 1 equal with 0, so x equals to -1, and then your y is 4. So this is your point of symmetry, -1, 4. Okay, so next you need to find the x-intercept. So to find your x-intercept, you need to solve the quadratic. So equate your quadratic function to 0, and then you will have your x either -3 or 1. So here is our graph, -3 or 1. So our point here is -1, 4. Okay. So that is our first K1. So the region M is between this curve, y-axis and x-axis. So this is the area M that we need to find. So area M equals to integration from 0 to 1, and then y top minus y bottom. Okay, y top is this function. So 4 minus x plus 1 square minus y bottom is 0. Okay, minus 0 here. So that is another K1. And then you integrate this function. 4 integrate 4, you get 4x, integrate x plus 1 cube, x plus 1 square, you get x plus 1 cube over 3. Evaluate from 0 to 1. Okay, so you integrate, you get J1, substitute your upper and lower limit, you get K1, and then final answer, 5 over 3 unit square is your G1. Okay, so that is the area of M. Okay, next, for question 7b. Okay, question 7b, okay, they said that V1 represent the volume of solid when the region M is revolved about the x-axis. Okay, this is V1. Okay, V2 is the volume when M is revolved about the y-axis. This is V2. Okay, they want us to show that the ratio between V1 and V2 is 106 to 35. Okay, so to show this ratio, first we need to find V1 and V2. Okay, for V1, to find the volume, okay, formula for volume is pi times integration of outer square minus inner square function dx. Okay, so we have our graph here, x, y, this is your M. Okay, so from 0 to 1, okay, this is V1. So you integrate from 0 to 1, so outer minus inner, outer is this function minus inner is 0. So outer square, you must have square here. Okay, so you integrate this function. Before integrate, you need to expand the quadratic here. So 4 square is 16, 2 times 4 is -8, x plus 1 square plus x plus 1 power of 4 here. Okay, you integrate, you get 1 mark, and then you substitute the upper limit minus lower limit, you get another K1, and then your J1 is 53 over 15 pi unit cube. Okay, so that is V1. So for V2, you revolve around the x-axis. Okay, so this is our graph just now. This is M. So you need to revolve about the x-axis. So your function here will become, you integrate, okay, outer minus inner, but now x in terms of y. Okay, so your function must be in terms of y, and then your limit from 0 to what here? Okay, if you revolve of x, so 0 to 1. So here to get the value here, okay, just substitute. We know that when x equals 0, your function y is 4 minus, okay, 0 plus 1 square. So you will get your value y is 3. Okay, so here is 3. So you need to integrate volume 2 pi from 0 to 3. Okay, from 0 to 3. Your function, you cannot use the original function here. Y equals to 4 minus x plus 1 square. Because this one is y in terms of x. Now you need to find x in terms of y. So you just rearrange your function. So I bring x plus 1 square to the left hand side. So 4 minus y. And then square both sides, you get x plus 1 equals to square root 4 minus y. So x will become square root 4 minus y minus 1. Okay, so this function that we are using in V2. So that's why negative 1 plus square root 4 minus y square. Okay, respect to y. Alright, so this is K1, and then you expand this function as usual. As usual, you will get this one, and then integrate another K1, substitute your upper and lower limit, minus upper minus lower limit, another K1, and then your J1 is 7 over 6 pi. Okay, so now we already find our V1 and V2. We need to show that the ratio is 106 over 35. So just divide these two volume. You will get 106 over 35. So you already shown that the ratio is same as what the question wanted you to find. Okay, so that is your answer. Okay, I think that's all for this video. So don't forget to calculate your marks, okay, for set 5, and then please write down the total mark you get. Section A is over 25, section V is over 75. That's all for this video. Thank you so much for your attention.